Okay, my name's Calum. Thanks for coming today on the last day of Next to talk about perfecting voice applications. We're going to be talking about our new speech models, talking about how to apply it. But before we get started, I'll tell you I'm Calum Barnes. I'm responsible for the product and engineering teams for the speech and voice features here in Google Cloud. I have with me a couple colleagues.
My name is Kurys. I'm the product manager for speech to text too.
I'm Jeff Kurys, and then I'm a customer from Bell Canada.
So we're going to be talking about a few different things today. I'm going to start off telling you about the speech APIs. Everything has changed in the last year since last Next. We'll talk about our brand new foundation model for speech chirp that maybe you heard about in the keynote or as part of the other Vertex AI talks. Jeff is going to talk to you about how they're using speech technology to change the business at Bell Canada. And then Harris is going to give you a preview of some of the things that are coming next to the speech APIs, focusing on speech fine-tuning and improving the models even further using our foundation models. But let's get started talking about the cloud speech APIs. Most of you, if you attended the keynote or other sessions so far, probably have heard about Vertex AI. And our speech models and speech services are in the model garden, and we expose actually over 750 different speech models, including speech-to-text, text-to-speech, first-party proprietary models from Google in the model garden. But we make those available through the speech-to-text API. But before we get into that, I think it's important to think about everything that Google has done in the speech space over the last 20 years. So Google's been working on speech-to-text for over 20 years now, and there have been a number of advancements in that time. So probably some of you are familiar with the very early products like voice search, dictation, and Gboard, and some of the more recent ones, Google Assistant or Recorder and Dialer features on the Pixel phones. In 2016, we launched the speech-to-text API, which was the first version of making this available to customers, to enterprise customers. Since then, we've continued to innovate and invest in research for speech at Google to push forward what's possible and bring speech technology to more and more both customers and users. Last year, we talked about our state-of-the-art conformer models, which are still available today, the fastest and highest quality streaming speech models available. And today, we're going to talk about our new research, the universal speech models and the Chirp Foundation model. All of this has come together across Google to create this set of services. So even if you've never heard of the speech-to-text API or used the speech-to-text API from Google Cloud or experimented with Vertex AI, you probably have experienced speech from Google, whether that's using Google Assistant or Google Voice Search, whether it's dictating with Gboard on your Android phone, reading subtitles on YouTube, live captions on Meet, the list goes on. But what we've done in Google Cloud is take all of this research in all of these areas that we've used to perfect voice and speech for a number of different 1P applications, and we make that available to enterprises and developers in our Cloud Speech API. The Cloud Speech API within the Vertex pre-trained APIs gives customers super high quality out-of-the-box models. I talked before, we support over 135 languages, and we have multiple variants for multiple different use cases like telephony, dictation, long audio in those languages. So you get over 400 out-of-the-box models that give you super high quality to get started today. But you can also use the API to take this further, customizing your output with punctuation, diarization, as well as fine-tuning towards specific words and use cases. And today we're excited to announce new features on fine-tuning that Harris will talk to you about later. First, though, we want to talk about our recent GA of the V2 of the Speech API, which happened this past July. The V2 API is the next generation of speech-to-text serving at Google. Like I said in the previous slide, we've been making speech models available to enterprises for almost 7 years now, and it was time to modernize some of that infrastructure. And that's what we've done with STT V2. So it's the same great models that we were exposing before, the same endpoints and features that you're used to, but now it is available for data in-use residency in any GCP region, and also in the US, setting us up for FedRAMP High and IL4 for those of you running protected workloads. and other individual requirements for data residency across the world. It also exposes new tools for service controls, encryption, and fine-grained permissions on individual models and recognizers, so that regardless of your application for speech-to-text, you can be sure that we can meet your enterprise requirements. Finally, we added a new endpoint that I'll talk more about in a second called Dynamic Batch, which allows customers that have workloads where they maybe have large amounts of speech that they want to transcribe, but they are not time or latency sensitive, to transcribe them over a 24-hour period instead of getting results right away. This allows us to take advantage of gaps that we have in our infrastructure usage and provide transcription at much, much lower costs. Our hope is that this enables even more use cases to be able to take advantage of automatic speech recognition technology by bringing it in at a much lower price point. V2, as you'll hear about, is also our starting point for new models and new features, like our Chirp Foundation model and custom model fine-tuning. In addition to these new features, we've also listened to customers and heard that one of the biggest blockers for adoption was the pricing of speech-to-text services. Everybody's use case is different, and the amount of value that you get from transcription can really vary depending on what you're doing. So we wanted to work with customers to make it possible to adopt regardless of what their use case was. So we've dropped the base price on speech-to-text 33% from 2.4 cents per minute to 1.6 cents per minute. And we've also introduced native tiering. So as your workload grows, your costs will grow non-linearly, all the way up to 83% out-of-the-box discounts for very large workloads. In addition, I mentioned dynamic batch before. So starting with whatever size of workload you have, you can transcribe for much, much cheaper if you're willing to accept the additional latency in getting the transcript back. Okay, so now that we've talked about that, I think we should talk about our new foundation model, which we also made generally available in July, called Chirp. So this is in addition to all of the speech-to-text models that we supported before, and Chirp is based on Google's universal speech model technology. So we have an initiative at Google called the 1,000 Language Initiatives, where we want to try to support the vast majority of the spoken languages in the world and support very well every language with more than 1 million speakers. But we knew that this was going to be a hard problem with the current technology that we had for speech-to-text and speech-to-text modeling, because speech modeling is a very data-intensive operation, requires a lot of labeled data, and you need a lot of data for each language. So what we've done with the universal speech model is created a universal model with one unified encoder that it was trained on over 12 million hours of unsupervised audio. So this is audio that we have not had to label or get human transcripts of in order to use it for training in a wide variety of languages. And this allows us to not only support more languages where we only have very small amounts of data, it also has lifted quality in a number of languages as well. So once we train that unified encoder, we then train decoders for each individual language that we support. And today we're only exposing 135 different languages through the Chirp model, but as we label more data in more languages and train more decoders, we'll be able to very rapidly add more languages compared to how long it would have taken us to add a single language before. So to show you some of the effects of this, you can look at the performance of Chirp on a variety of languages. And so you can see that we get improvements across the board here. So on common English academic test sets, Libre Speech, we achieved over 98% accuracy on English with the Chirp model. But for lower resource languages like Romanian, Polish, where we have a lot less data, we achieved over 300% increase in those, 300% accuracy increase on those languages versus what our current internal state-of-the-art was. And across the board on our YouTube data sets, we have an improvement across every language that we have data for when you combine it all together. You also get gains in what we call head languages like English, French, Italian, German, and Spanish, especially on very, very challenging data sets. So 98% accuracy will not be possible for every use case like it is on LibreSpeech, of course, but we also are achieving 88% accuracy on Coral, which is considered one of the hardest English language academic data sets. And much, much better than any internal fine-tuning on just that test set that we had done before. So we're excited to bring Chirp to a variety of customers in a variety of languages, and we will keep adding more and building on the foundation model of Chirp over time. But it is generally available in these languages now, in the speech-to-text v2 API. All right, so now to talk about how you can use these models, Chirp and V2 and our existing models, in everyday applications to make it better for your users. I'm gonna hand it over to Jeff from Bell Canada to tell us about what they're doing.
Thank you, sir. I'll walk you guys through how we're using it today. Just to start with, for those of you that aren't very aware of what Bell is, basically for the non-Canadians, Bell is pretty much Canada's largest telecommunications network. We sort of split it into 3 divisions. One being wireless, so roughly 10 million wireless subscribers, wireline, so your home phone, TV, and internet services, about 9 million subscribers, and then there's a media side to the business, whether that's running mixture of ads, TV, radio, and so on, but that's sort of the overview of what we are. For myself, I think it was about 3 years ago, they brought me in to lead this newly formed speech analytics group. So think about it as taking all of our call center information, or call center calls, turning them into text and trying to drive value out of those. Slightly different approach from what most people do. So most people, the first thing they want to do is go in there and just build VAs and chatbots and so on. We sort of took a slightly different approach where we were going to build AI products that help drive the business and improve the customer experience across the business. So we sort of brought together a bunch of NLP data scientists, some analysts to sort of help prove out the business cases, and then product managers to actually run each of these solutions as its own product. So from there, where we sort of led to how this evolution would work, if you think about a general call center and how it kind of works, you have 2 probably sort of normal ways in which you would call listen in the past. So one being, if you're old enough to know, is sort of a YJack solution, or what you would probably do as like eavesdropping on the customer agent interaction today. So you would do that in real time and potentially provide real-time feedback to that agent. The other is basically going into a tool like Variant, where you're kind of listening to those calls after they happen, maybe days or months or weeks after. But for the most part, all you're really doing is probably listening to maybe less than 1% of all those calls. So when you think about that, for somebody who's sort of receiving about 10 million calls a year plus, even on those 10 million calls, it's about 500,000 minutes of call listening. And then you kind of do that backwards math to kind of figure out how many resources that would take. That's a lot of resources that are just dedicated to call listening. And the other thing that comes with that is that bias, like, is every listener the same? Did I forget them to look for certain topics? So did I ask them to look for empathy? And if I didn't ask them to look for empathy, did I have to go back and redo all that call listening? So the way that we've kind of approached this now is we internally term it a virtual coaching assistant, but that virtual coaching assistant listens to 100% of all calls, and then we're able to go back and rescore all those calls for different attributes that we may want to go back and sort of analyze. And how we did this sort of at a high level, here's kind of the high level architecture of how this kind of came about. For the most part, you can imagine, for us anyways, there's an on-prem stack of telephony systems that sit there. From those, we kind of stream them in this is a very high level explanation, but we stream them into that speech to text pipeline. We then use a series of other connectors behind that, whether data flow, pub subtopics, and a variety of other things. Write them into structured databases and then run them through the entire sort of Vertex AI stack. When we originally built this at the time, sort of Vertex AI was a work in progress at the same time, so we were sort of building all these things as Google was sort of mastering them as well too, so it was a great experience to kind of get them all in place. The other thing too is now we've relied on these outputs so much that they're pretty much ingrained in a lot of our day-to-day operation systems. some of the key areas that you'll see here. The top three are probably the main three that we kind of focus on, but sort of that sales enablement area, a making it right program. So, trying to sort of intervene in conversations and interactions that just felt like they went sideways that we just want to immediately try to correct. And then just general improvement of the customer experience. So with all this coaching and all these tools, how do we just generally make that experience better? And we sort of found enormous gains through these speech-to-text applications. Here's a list of probably 6 that are sitting in production today. Some of my favorites here probably are what we would call agent language quality. So if you think of this, what this is at its core is basically evaluating the conversation that the agent's having with the customer and trying to evaluate, was that agent clear enough in how they're speaking to the customer? Do they stutter? Are they speaking too fast? Are they speaking too slow? Are they sort of is the customer constantly looking for clarity from that agent? And to be honest, there's probably no way to do that at scale in a sort of old world perspective. So now we're able to do that at scale on 100% of those calls and sort of evaluate those agents and performance manage those agents based on clarity. Another amazing one too, which was pricing representation. So you could think of it as a day-to-day telco customer. You're kind of calling in, I'm doing an adjustment on my bill. Maybe I'm adding a new service, removing a new service. What we're doing here is ensuring that that agent is actually sort of clearly explaining to the customer what those changes and impact on the bill is going to be. And if they didn't do that, we can then sort of fix that with a few different ways of attacking the problem. Some of it could be, again, going back to the agent coaching to make sure they're always explaining those issues. It could be further documentation or further explanations that we actually send out to those customers. So there's a few different ways that we could tackle it, but this was a huge use case for us. And then the last one that I'll sort of touch on a bit is sales pitch quality. I'll go into that right now, and this is probably our premier speech product that we've put together. I'll walk you through the flow of how it works. So basically, if you're a customer calling in, I want to buy internet. One of our sales inbound reps sort of picks up the phone, talks to the customer, and then sort of closes on that sale. So we sort of transacted, we finished the sale of that internet product. The key thing that we sort of push for, as any company would push for, is cross-selling and upselling on top of that product. So I've sold my internet service, now I'd love to go in and actually sell them some wireless services. So hey, let's go in, make sure the agents are pitching correctly and make sure that they're pitching those wireless services. So one way that we looked at this was, are they even making that pitch? So more times than not, the agent's making a pitch to the customer and they're trying to close that sale. But then the added value on top of that ended up being pitch effectiveness. For us, pitch effectiveness kind of boils down to 3 areas. Those 3 areas are exclusivity, so language around like, hey, this is a one-time deal, this is a deal specific for you as an individual, and then also mentioning highlights around high speed or network quality, basically how good our network is and how good it'll sort of run your different services, and then explaining the planned features in full form. So for us, those are the 3 key elements that we saw as sort of a premium pitch and how to kind of better sell as an agent on the other side. Within the first 30 days of launching this sort of pitch effectiveness model, we sort of saw a 24% increase in adherence, which is massive. I think part of that ends up being like, here's a recipe for you to sell more and for you to make more money as an agent. So like, if you put yourself in their shoes, how do I make more money? And these are the things that we need you to do to make more money. And once they see that it's actually working, it's something they'll easily follow. The next piece is that sort of then translate, you're not going to close on all of those, but what it did translate to is a 15% increase in cross-sell, which is massive. So if you think of every opportunity you're getting in, you're kind of closing now 15% more of the time. So like for any business out there, regardless of the cost of your products, if you can sort of lift by 15% within 30 days, it's a massive win. So this is one of our biggest products from a speech AI perspective that kind of allowed us to continue doing a lot of the work you do. So if you think of, if you're in my shoes on the other side and how do I sort of continue to get my company to invest in me to do stuff, you got to anchor yourself on value add products. So this was probably our biggest value add product that allowed us explore into all the different initiatives. So next steps for us. So one of the things we have at Bell is we sort of have this B2B offering where we work with large enterprise customers. These large enterprise customers we provide all different services to. So one of the things that we've learned through this whole process is how to effectively manage, 1, an ML platform in cloud, 2, this end-to-end speech-to-text pipeline in cloud. So what we're going to do now is we've brought this to market, and we're going to start offering it to some of our enterprise customers as a service. The next piece is then applying all the data we have against Vertex Gen AI use cases. If you think about that again too, the key thing to these Gen AI use cases is you need data to sort of provide value out of. The great thing that the speech-to-text services have done, it's created sort of massive amounts of data. So we basically have tens of millions of calls transcribed, sitting in structured BQ databases that we can now leverage and throw against different Gen AI use cases. So, and for those that are really close to it, all it is essentially an API call through a managed notebook or even through a direct SQL statement. So it's allowed kind of our developer team to go crazy here. And then finally, which Harris will walk through next, is kind of collaborating with Google on some of these speech fine-tuning initiatives. There's obviously little pieces of language throughout your conversations that get transcribed incorrectly, and what we've seen is the better the transcription, the better the model performance. So even though the transcriptions come through at a very high level right now, the better that we can make them, the better the models perform, and then the greater the output at the end of the day. So for us, we're very motivated to work with these guys to kind of help improve that. So with that, I'll leave it off to Harris to kind of explain to you a little bit about what they're doing on the speech fine-tuning side.
Thank you, Jeff. So speech fine-tuning. As Calum mentioned, we do a couple of different things. On speech-to-text, we try to offer the best out-of-the-box quality for the majority of the use case that we have for our customers. However, we are seeing that whenever we see the use cases, accuracy is not a single metric that is the same for everyone. So we try to come closer to as close to our customers as we can. So how do we do that? We do it with pre-trained models, straight out of the box. You call it through the API, either version 1 or version 2. You do it through Chirp, multilingual model, very big one, non-streaming, but you get the out-of-the-box quality and the robustness of a very, very large speech model. We do it through biasing, when, for example, you have a couple of product-specific names to your company that you want this speech model to recognize correctly. But the final step is to try to condition the models around both the acoustic conditions that it listens in your use case and also the lexicon. Let's see how we do that. So here's an example of a real example, actually, from a call center at Bell. So you can see that this is a conversation between an agent and a customer. Hey, I live in Montreal and I would like to purchase Bell 5 Internet. Now pay attention here, because you can see that Montreal, unfortunately, because of the acoustic conditions, because this thing is getting streamed through telephony, you can see that because of the sampling rate was lower, you can see how it was mistranscribed here. And at the same time, you have a product-specific name to Bell, which is called 5. Because the statistical representation in our training models 5 has a much better representation there, you can see how it was mistranscribed. If you multiply this thing by the load that Bell, for example, has, which is 500,000 minutes per day, you can see that only 2 words out of 8, basically you throw out your downstream applications, whether that be analytics, agent assist, or anything else. So how do we do that? Again, as I mentioned previously, there is a mechanism for biasing, right? In essence, you tune the language model, you tune the weight of the language model to kind of like condition it to keywords. But that is not enough. So how we do it? Basically, we offer our off-the-shelf ready models to be fine-tuned. Specifically, we attach at the end side of the model adapters, and we perform adapter-efficient fine-tuning. You as a customer come, and in your tenant project that you have in your GCP, basically you have a bucket with at least 100 hours of audio data, and we perform the training for you. Specifically, that happens through the console, through the UI, or through the API. You point the model the base model, which means the language of your choice and the locale, and the GCS bucket that has all the audio data, and then we perform the training. That specifically means that you as a customer end up with only one model, and as Google, we don't have any access to that. Your weights are your weights, your IP, which is reflecting your dataset, is only your IP. Training happens in our TPU V2 and V3, and it takes about a day, maybe two, in accordance to how many audio hours you grant the model access to consume. And last but not least, this is all available through the V2 API. Now, what happens as soon as you have trained the model? With the two-step process, you can automatically benchmark and you can automatically deploy. Benchmarking, how it works. Basically, on another GCS packet or in the same one, you have a separate directory, which you have audio and text. We suggest about having 10 hours worth of audio with a corresponding ground truth, so we do the benchmarking for you. And then with a simple click into our Google Cloud console, you can deploy the model into whichever region you want. How that thing, though, translates to the end, at the end in production. On the vertical axis, you can see how many hours of audio data we have provided our model into our internal testing here. And you can see with only 100 hours of audio, you can see that we get about 15% relative word error improvement. If you crank that to 400 hours, you can see that we're getting gains of 30 to 35% relative word error improvement. And mind you, it's not across the board. It's specific to your use case, your product names, and exactly the audio conditions that we see in your use case. That is massive for our customers. Again, tying back to the story that Calum said, coming as close as we can to our enterprise customers.
We'll be around afterwards. Thank you so much.
Have a good one.
And yeah, don't forget to rate it if you can. Thank you.